Good morning. We're going to hang out just a little longer, see how many decide to join us this morning. Hoping you guys had a great weekend. We're able to relax just a little bit. I know that you have work that you're working on. I know that you're still stressed, and that's okay. I think we're all trying to figure out how this is normal. Oh, that's so nice to see somebody type back. Thank you. First session today was at 9:30. I'm sure everybody was a little tired, so it's nice to have some communication. I appreciate that. Please, as you get into week 2, really get into your routine again. Don't get off task. Hi, Lily. Hi, Reagan. Make sure you stay focused. I am trying to make sure that you guys are still practicing. I am leaving so much up to you guys to, oh, look, everybody, top of the morning to you. That's so fun. I like that. It's past St. Patrick's Day, but I'm digging that. Good morning, Sarah. Good morning, Scarlett. I know that I'm not requiring as much as I would have if we were in the classroom. That is, I guess, kind of prep for how it's going to be when you do go on to college. I know for some of you that's a very long way away, but it's good to kind of catch a feel for what it is to stay on track, to practice on your own, and then be held accountable for maybe only 1 or 2 things. The no-re stuff, again, is required. I also want to let you know that I have graded the late work. It did take me a little longer with some of it because I was having to grade test corrections while staring at the computer screen. You will see those grades go in ASAP. I'm finding, as much as you guys, that I think we all, for a lot of reasons, would like to be back in the classroom. When I finish for the day, finally at 2:30, I pretty much start teaching 2nd and 4th grade. So you can only imagine how fun that is, because I was already told once, Mommy, you don't know math. So that was fun. Please make sure that you do stay on track. So the first thing that I do want to ask is if you have any questions on, the E&C pages. I think it was, maybe I'll be able to write this morning, 342. Do we have any questions before we get going on that first E&C assignment? I know I did not require it, so to speak, but don't be surprised if I pick 1 or 2 of them and make 1 or 2 of them a requirement. Again, it's a lot less than what we've been accustomed to, but at least what you're looking at is something doable that doesn't feel like it's so over the top. So if you have any questions on the E&C pages, I have no problem. I'm hoping that me working out the problems came in pretty handy. So I just want to make sure that we're okay with the E&C pages. If for some reason you do have questions on any of those, you absolutely should feel free to ask, and that way we can get rid of any issues that you see coming up. Make sure that as you work through any, you continue to email me your questions. I didn't have any emails over the weekend, so either we needed one heck of a break or we're feeling pretty confident and comfortable with everything we're doing. So I'm hoping that we're feeling confident and we're comfortable. So what I do want to do right now then, if there aren't any questions, is push forward and talk about at least some things that I do believe are shortcuts, that they are not necessarily, this first part isn't necessarily a requirement, it's just a shortcut. So if you have any questions, type them in on the side. If you don't, I'm just going to keep busting through and get you guys out of here for the day and concentrating on practicing the stuff, not stressing and having to listen to all brand new stuff all day. So I do want to talk about this parallel line with similar, this parallel theorem with similar. And it does say that parallel lines will divide transversals. And that's the catch right there. Multiple transversals proportionally. Now, the reason it's going to do this is I need you to consider right off the bat, parallel lines share the same slope. And because we're not going to adjust that slope any, they should hold their intersections proportionally. Because slopes are consistent, they're linear, there isn't going to be any change in how it affects one line to the next. Now again, they're not going to be necessarily equal, but they will stay proportional. So when we look at parallel lines, and we talk about two transversals. Okay, we'll just keep it real simple, and I will make them look like it's not necessarily a triangle to begin with. Could have been a little straighter, I apologize. What we're looking at is at these intersections here, we do have this idea. Let's go ahead and add one more just for this purpose. Because all of our lines share this same slope, the way they intersect this transversal will have the same effect as that transversal. So technically, what happens on one side should happen on the other. And it's kind of like playing the matching game. So for example, if I want to compare AB to BC, and I want to talk about what it's going to be equal to, whatever pattern I've created on this side will match the pattern that happens on the other side. So if I said this over this, now I have XY over YZ. The pattern has to stay the same. They are proportional. So everything that we've talked about is about the pattern. So even if I adjusted and I said, let's talk about CA, so from C up to A, and that's going to have the same pattern as, let's talk about BA. So C to A over B to A. I would want to make sure that it holds the same pattern on the other side. Z to X, Y to X. So C to A has to match Z to X. B to A would be the same as Y to x. The patterns have to match because they are proportional. Now, it could be because of our means extremes product theorem that when we cross multiply, it still will hold. What if I said a b to xy, ab to xy, and then I said let's talk about ac, and I wanted to fill in that last part. As I'm looking at ab over xy, and I then tell you that I want it to match with ac over something, what might it be? Perfect. So we do want this AB to XY, AC, and then it would have to match with XZ. Perfect. So what happens is when we do then look at how this matching game works with our triangles, sometimes we have to be very careful because, again, I cannot stress this is a shortcut. It is not a requirement. It is a shortcut. So I want you to even consider that in real life. Shortcuts, they're not necessary. We just know that they help us get through the problem a little bit faster. So let's go ahead and let's talk about some of the problems that we've already seen. And I'm going to go ahead and put this in here. And I want you to take a look that we do have these parallel lines. And typically what we've seen in the past is something along the lines of maybe 10, 5, 6, x, and then we would have something like 8 and y. And here's the problem. You can use this theorem as long as it holds to its rule, which says the parallel lines cut the sides proportionally. So I want to do this because before I tell you why it's a shortcut, anybody want to tell me what you think y is supposed to be? Like immediately your gut tells you y is supposed to be. I get my triangle is not to scale by any stretch. But what I want you to tell me is if you had to quickly answer this, anybody want to tell me what you think y is? Right? That's exactly what almost everyone's going to say. We're going to say that it's 4, and Reagan, you're actually correct. It's 12. And I can't tell you the number of people who will immediately say very fast, it's 4. So you're right, Landon. 90% of everybody's going to say it's 4. Now, Reagan, even though Landon probably knew it was 12, you are absolutely right, it's 12. And the issue is we have to remember that the parallel lines, I almost said sides, divide LN and LP proportionally. They have nothing to do with MR and NP. So our theorem does not, is it effect or affect? I don't know, which one is it? To act on. The theorem does not affect or effect. Affect. I think it's affect. So when we do this, X should be pretty fast. Does anybody want to tell me what X is? Again, because LN and LP should hold the same match. They should match. We played the matching game already. So do we already know what X is going to be? Yep. X is definitely going to be 3 because 10 over 5 should equal 6 over X. So X is 3. We know that that should be the case. Shortcut, fast, perfect. Thank you, everyone. Hi. I see McKenna's back and Irene's back. Hi, Natalie. Hi, everyone. Perfect. Yay. Yay. The problem is, though, is when we go to find Y, we have to still stick with our small triangle LMR, hush, shh, which was 10, 6. Oh, yeah, this is really not to scale. I'm sorry. And then we have to work with LNP, which over here was 15, and Y. So our scale factor for this is actually this 10 to 15, which is 2/3. Our scale factor is 2/3, not this 2 to 1 that a lot of people want to consider it. So the difference between our theorem and what we actually have been doing is the theorem is a shortcut for the sides. Our scale factor has never changed. So that's why now our 2/3 and our 8 to Y is what we need to worry about. And that's why we find out Y is 12. It has to still hold that scale factor. So we cannot abandon the scale factor. That is something that is going to be different than this proportional line theorem. It is just a shortcut. It does not remove the need for scale factor. So when you're doing this, be careful. Our sides being proportional is different than scale factor. They are separate. Our triangles are going to still be similar by angle, so it will still put those two together. Then the only other thing that I want to talk about along these lines is, again, it kind of feels like a shortcut. And it's segments in our segments in similar triangles. So you guys may or may not remember, but I always seem to think about how when I was a kid, there was this toy, and of course, I have one in my classroom. I didn't think to bring it home, and I'm not sure what it's called. I'm trying to Google it right now. To see if, oh, good gravy, it came up. I'm really excited about this. Yes, expandable. I found it. So these are the things that my dogs are having a fit. These are the things, and I hope you guys can see this. I'm trying to figure it out. But these guys, if you push them in, if you pulled them apart, everything kind of moved at the same rate. So apparently nobody wants to be quiet today. So you guys can kind of see that that all the arms moved in and out at the same pace. All of this work. So that's what I kind of think about when I think of what we're talking about. I also like to think of a slinky. Like I know that we're pulling it out and pushing it back in, and it all happens at the same time. So it's kind of the same idea when we're talking about our, when we are talking about these segments in our triangles. So we do have our angle bisector theorem, and it's specifically for similar. And it's with our proportion. You guys have no idea. I have one dog that won't stop growling, and I'm not quite sure why. The Doberman Layla, who shares the name of some of your dogs, won't stop whining. They have been quiet all morning, and I have no idea why they're mad right now. So it's kind of funny. So pardon me if you keep hearing me shush someone. With our angle bisector theorem, this time our triangle is going to exist. The last time we talked about angle bisector, we were talking about equidistance. That's not what we're looking at here. We're looking at a bisector going straight through our angle. We will see that there's been something bisected. But what I now have, instead of a triangle, I have 1, 2, 3, 4 parts. And I'm just going to name this A, B, X, and Y. And I did kind of keep them organized, where A comes before B, X comes before Y. That's totally just for organization. And it does say in our theorem that if an angle is bisected, the bisector divides the opposite side proportionally with the sides of the angle. So if I'm looking at what this is, the opposite side is this guy. That's our opposite side. That side is opposite of the angle that we're looking at. Get upstairs and do your homework. Yes, you do. And the sides of the angle are these two, because those are the two rays that connect to form the angle. So what we're looking at is, however I want to play the matching game with A and B, I'm going to make sure that it's identical with X and Y. So when we do set up this ratio, if I choose to say A over B, then it would have to be X over Y. Now, I could rearrange this again so that I work with the pattern. So if I want to say A over X, then it's going to have to be B over Y. Or if I want to talk about Y over B, the same thing would have to go in the same direction, X over A. But notice what I'm not doing is I'm not crisscrossing through our angle bisector. Again, that has to go with our means extremes ratio and means extremes product theorem. So do not cross through the bisector. Hush. Now, I do consider this probably one of the easier problems because the minute you see it, it's pretty self-explanatory. Again, you can see that this is straight. There's no right angle, point to a line type situation. You're going to see that that guy specifically is bisected. And if I chose to say, let's talk about 8 to 20, X to 14. And if all I'm trying to do is figure out, solve for X, it's pretty easy that we're going to end up using this theorem. So create a pattern as long as you don't cross through your bisector, 8 to 20, side to side, X to 14. Come back to the same side, follow the same pattern, bottom to top, bottom to top. And when I cross multiply, you end up with 20x equals, yes, I'm going to go to my calculator just in case, and I have 112. When I divide both sides by 20, I end up with x equals 5.6, which we know is 5 3/5. And that's it. It's the whole purpose of that theorem. Because we keep talking about this idea of as long as the cross multiplication stays consistent, we're okay with switching them up a little bit as long as we don't break that cross multiplication equivalence. The one thing that I do want to make sure that you are checking all the time is, have you actually created equivalent proportions? Again, I want to make sure that I don't make any mistakes and match up the wrong thing. So when we ask, are they truly equivalent, you have to know how to check. So the last thing I want to do is make sure that you are good with your proportions. All right, so what I want to do, and we'll end with just how to check, is equivalent proportions. And you are just going to be asked, are they equivalent? And it's going to be a statement that you're going to check. Right away, does anybody know if this is yes or no? Right off the bat, is this a yes or no situation? What are you doing? What are you doing? And it is a no situation. I will tell you. So here's how to check. It is no, and that just feels like a 50-50 guess, probably. And I agree, Sarah. I'm not quite sure. You want to say no. So here's the trick. Always, no matter what, cross multiply. And that's why right away when we started everything, we talked about this means extremes product theorem. And what we want to do is always use our cross multiplication to check. I don't care how ridiculous the proportions look, always cross multiply to check. So in this first one, if I crossed multiplied, I'd end up with m times t, and if I cross multiplied here, I'd end up with n times r. That's what it's supposed to be. I don't know if you guys can hear them whine, but it's kind of funny and annoying all at the same time. Layla. So in our hypothesis, this is what we want to have happen. That's part of the hypothesis. So then when I check what's going on the other side, I want to make sure that it's supposed to match. So when I cross multiply here, I end up seeing that it's actually n and m that cross multiply, r and t that cross multiply. They're not the same. Shh. And since they don't match, they are not equivalents. And that's our final answer. So what we're looking at is make sure that you always cross multiply to check. Now, sometimes it might not, now that you see that and you're like, oh, I could totally check that mentally, I can see that the m and the t are supposed to match and they don't match over here. So right away I can say they're not equivalent. You just got to make sure that you show why. You cannot just say yes or no without showing why. So the very last one we're going to look at and your book does a really good job of this whole does the pattern fit? And you can go ahead and look at those pages if you want, because they talk about just fitting the pattern. I am all about cross multiplication. Don't even worry about getting your mind bent and trying to see, do they match, don't they? So if I say if x over y equals 3 over 5, then x plus 3 over 3 equals y plus 5 over 5. Check. I can guarantee that one's not going to be as easy to say yes or no to at this point. So we're going to cross multiply and we're going to check if they're equivalent. The only catch is, don't forget that you need to make sure that you distribute. So when I cross multiply over here, I end up with 5x equals 3y. Again, this is from the hypothesis. This is what we want. When I cross multiply over here, I need to make sure that I don't forget to distribute. So this is actually 5 times x plus 3. This is 3 times y plus 15. Oops. Too fast. That, I might surprise you. I don't know, McKenna. I haven't done this one. I made it up and I was trying to make it a no, but you know, who knows? I end up with 5x plus 15 equals 3y plus 15. Now, when I cross multiplied, I've done the algebra correct. I've done the arithmetic correctly. Now what I want to do is combine like terms, but I want to make sure that what I'm looking at is still, do I have on one side what I'm supposed to have on the other side? And I think you could agree that my 15s, if I combined like terms, they're going to cancel. And what I'm left with is the 5x and the 3y. So these guys are equivalents. Now, I actually was trying to make this a no again, but it is. So they are equivalents. Okay. So what you're going to see today in your Google Classroom, I'm going to post these notes. I am going to post, again, the practice study guide so that you have those to look at. Did anybody find any questions that you had from anything last week? The E&C pages that I later posted the answers to. Anything from the No-Re account that you should be working on? I am going to have to make contact with folks today to make sure that everybody at home is trying to stay on top of things, reassure parents that I'm here and we're chatting. I am going to Zoom. I am not changing the time of class. The class will still be at the same time, so please don't be surprised with that. But I need to, in the next couple days, make sure that we're all staying focused, staying on task, and if anything, working harder now that we have an opportunity to, and not getting distracted by everything else that's going on. So keep yourselves motivated, keep yourselves focused. And again, if you have any questions, please ask. I'm going to provide you with practice questions today, but keep on top of the requirements, because when I say they're required, I will make sure in Google Classroom you see very clearly that it says required. So if there are no other questions, I'll hang out just for a little bit to make sure that you guys are all good, and check Google Classroom for tomorrow's work and tomorrow's assignment and where we're going to meet, if it's going to be here live streaming again or if it's going to be via Zoom. And if it is by Zoom, I will give you the link. The only thing is you have to make sure if we go to Zoom, you use your SailorNet accounts to log in. That way we have unlimited time. So if there's any questions, please ask. If not, I'm going to sign off here in about 30 seconds.